Yeah, there's
One.
Rust in there.
It is not yet live. It is still,
I don't know.
usually it takes 15 seconds or so.
So we're now streaming to Rust.
Yes, we are now streaming to the correct place.
That's no one on Jitsi.
For all the M1 stuff at work.
All right.
I feel so bad for the DevOps guys.
Would you guys get to,
They're gonna.
All right, we're live.
Okay, so sound works, no one online, we'll go with it. Okay, welcome everyone. My name is Daryl Spencer. Your guest presenter for tonight. We'll be speaking on closures in Rust. First, I'd like to thank Vivint Smart Homes for hosting us tonight. It's very generous of them, especially with the food and everything. It makes it nice to have a place to be. My background is I lead the software development team for a startup company called Cartera in northern Salt Lake. We make a machine that we sell for about $500,000. It weighs 800 pounds, and the size of a refrigerator. That's used in biological research. Our machine was used by Eli Lilly, in fact, to develop an antibody treatment for COVID last year. So, this machine is near and dear to my heart. And in this machine, I had 200 megabytes a second of image data that I had to process. And so I thought of doing that in C++, and I really didn't want to go back to C++ to do that. So I taught myself Rust. I consider myself an intermediate level person, which means I know enough to be dangerous. I know the parts that I use. There are parts that I don't use that I don't know so much. So I would like this presentation to be not just a lecture, I like to be more a discussion. And if people, even if they have a small syntax question about something, want to stop and discuss that before we go on, because I know if we were going to other parts of the language doing other things, I would be lost myself. So I want to give credit to this person, R. Stropik. So I was writing my presentation on Rust when there's a meetup group that meets online in Linz, Austria, where he did a presentation that was 45 minutes long on closures. So I have used some of his material. He did a very good, long, in-depth presentation based upon this. The first link here is a blog article he wrote in German. For those of you who don't read German, Chrome did actually a pretty good job in doing the translation. But his presentation was very much to the video format, and I hope this to be more of a discussing thing. So I've kept the material a bit shorter, so we have a chance to discuss and go back and forth a bit. Okay, so before I go any further, who here has written a closure in Rust before? Okay, about a third, maybe a little less than half of the people here. How many here have never written anything in Rust before? Okay, so
There's a few people.
we have at least one honest person in the room. Okay. So, what are closures? So this is my point of view on it. I'm not quoting an official source here, but I like to think of closures as anonymous functions that when you write them are able to capture the values of their environment, the variables that are around them. So that it makes it very easy to write these things. You can also think of them as an anonymous class with a single function on it. Because if those variables that I'm capturing in the environment, you could think of those as your private member variables. And depending on how you capture them, they could be read-only or they could be mutable. And it's all around to service that one function. And that function has a type to it in that there's types that go in and types that go out, but the closure itself doesn't have a name. It's a thing that you call, and we'll go through that a little bit later. So closures are based upon traits, and closures closures come from, and there's three types of closures here. So this is from the namespace standard ops blah. So first one, fn, is a simple a function, which means it can grab variables around it, but only read-only. If I take these variables, I'm not going to modify them. I'm just going to use them in the context of whatever I had to do inside my function. Function mutable means that when I capture these things, I want to capture them with a mutable reference, meaning I reserve the right to change their value for some reason. If you think of this as a class, in object-oriented programming, we often have a class because we have state that's private that we want to mutate and change, not anyone else know it, and I want to do that in my closure. FN once, I have not used that a lot myself. It's one where the closure consumes the capture variables and you can only call the function once on that closure. Why is that useful? Well, I've seen cases where people have used the code where they're going to change the ownership of the environment to some other closure after that, or maybe they're using an iterator and you often use an iterator once for a loop and you don't use it after that. Now, why not just use function pointers? Well, function pointers, you can use them in Rust, but they can't capture their environment. So in this example here, let's see, when I point on my screen here, it doesn't show up on there. Does my mouse show up on your video at all?
No, it doesn't.
Okay, well then I'll just describe. So here at the top we have a function called calcimprint, where I take an x and a y in, and I take a function. So notice here the function here is a lowercase fn. This is a function pointer, where it takes two integers coming in, two i32 assigned integers coming in, and an assigned 32-bit integer going out. So if we think of back to the Gang of Four pattern book, there's a strategy pattern, or inversion dependency, where I can say, I'm going to put into my function saying, when you do this, this is the thing I want you to use. Okay, you don't need to know about it. I'm just going to provide you the function you're going to use to do the stuff you want to do. So this complex function, calcimprint, I want this thing to do the math for me, this function called calculator. Okay, that's great. So I can call it with an x and a y and get a result back, and that's great. But let's suppose that my function calculator, what if that needs to be a bit more complex? What if there's other context that I've set up in my environment that I need to use and want to refer to, and those values may not be defined at compile time, and I want to use that. So this example is down here at the bottom. So if I say that there's this value of z equal to 3, and it's really important I use this value c in my calculation, and I want to define down here this syntax here of when I do this x and the closed bars here, that's a syntax for saying, hey, that's what I'm putting into this closure I'm going to call. And little syntax shortcut here, in Rust, if I have just a one-line closure, a one-line function, I don't need to put curly Q brackets around it. I only need to do that if it's multiple line. I could do it, but it's just a little shortcut here. But down here, this one's a bit different, where they say, in this calcimprint thing, I'm putting this into here, saying, okay, I want you to call this. But down here, I'm going to say, no, what this function really is going to be x plus y plus z. I'm making reference not to just the variables that came into me. I'm making a reference to something that was in the scope of where this is being called, but it's not defined internally. And that is what a closure is able to do. I'm able to call and pull those in. The function pointer is not able to capture that in. That's the difference. So let's go to an example here. So if I use the fn, capital F, for the trait, by the way, backing up a little bit here for those who are new to Rust, traits in Rust, you can think of them as interfaces are to C#, Java, or other object-oriented languages or things, such things.
Can I ask a question from the last slide?
Yep.
I noticed there's a comment for that last line, the calcimprint, where you use z.
Mm-hmm.
If that was a move closure, would it work?
It would not work because the calcimprint, as I define it up here, is expecting just a function pointer, not a closure. This is little lowercase fn rather than big case fn.
Interesting. So there's no compatibility there at all.
Function pointers and closures are different.
Oh, interesting.
So the case I'm going here is where, okay, notice how I define something a little bit different here. Now I have calcimprint. I'm pointing with my mouse, I shouldn't do that. So calcimprint now has a little bit different syntax to it. Calculator has got this language around box dine function stuff. What's all that about? So in Rust, we often use structures. And structures can go on the stack. That's great. And we can do that because we know what the size of a structure is, so we know how to put that on the stack. But now let's think about interfaces. If I have an interface, it says I have, I have a pointer, if you will, to something that does what I want, that's going to do something for me, but I have no idea how big that object behind it is. So I cannot put that on the stack, that whole object on the stack, because I don't know what size it is. Because at runtime, I could have different objects of different sizes that support that interface. I can't do that, or this trait in the Rust case. So what I can do is say, okay, I'm going to use that pointer, and I'm going to use this pointer to call this thing. But since we're in Rust, like C++, we say, okay, we have to maintain this pointer, and we have to free this pointer in its memory at some point. We can't let the garbage collector take care of it for us. What can I do? So the syntax here means, capital FN means I have a trait, I have a closure, a type function that's going to have a read-only environment around it. And dyn is a required keyword now when I use a trait, which basically reminds you in the language that, hey, this is something dynamic here, this is dynamically typed, this is at runtime, you're going to be calling some object, you don't know what it is. And box is, think of it as a smart pointer. It's a container of known size, it's a structure of known size, and inside of it has a pointer that can hold on to your object. So I can put a box on the stack, and I can pass it around my program just fine, and when Rust realizes the right thing to do and cleans up the stack, it will free that pointer at the right time. So whenever I need to have a pointer on the stack and pass it around, or I work with something dynamic, I need to hold on to it like a memory variable, box is what you're going to be seeing a lot of place.
Is that a language keyword?
Box is in the standard library
Okay.
as a smart pointer. Dyn, so FN is a trait defined in the standard library, and dyn is a keyword in the language saying that, hey, this is something that's it's basically got a V table in it, like a C++ virtual class does.
It's what was that?
Anything with dyn, think of it like a C++, like a V table,
Okay.
virtual classes type thing.
Dynamic dispatch.
Dynamic dispatch. Thank you, that was looking for. So here I've defined this function here, where it says, okay, now down here at the bottom, I'm now able to define a case of where I want to say, I'm going to declare a closure here, where I'm saying I'm going to refer to X and Y and Z, and the closure is going to capture the value of Z in here. Whenever it can, it's going to try to capture these things by making, very often if you may want to use it, it may try to take a copy of it if it can. And this box here, new, means, hey, I'm going to be creating this structure box, and I'm going to initialize it. The smart pointer is going to be initialized to this object, this pointer I'm giving you. Hold on to this closure, please, sir. And then when that gets passed into calc and print, that box structure is being passed on the stack down into this thing where the closure will be accessed with this pointer and call this math for me. So it seems like a rigmarole here all to get this value Z in here. Why didn't I just define that in there? Well, because maybe I need to get Z from some other part of my program for me to do the logic I want to do. Like many cases here, we show a silly case to show the structure that's in here. So go back to the original one. The original one was just an ordinary function pointer to do the math for you. Everything about that function either had to be passed in as arguments or had to be defined in the code already. With the closure, I now potentially can grab values elsewhere in the code that I can use at runtime. So, but FN means immutable, read only. It's fine for me to work with a mutable copy of these things. Now, let's see. There. Okay. So, let's talk about ownership. In Rust, we care a lot about ownership. The borrow checker is something that many of us have or continue to bang our head against from time to time, where there's some basic rules. It says if I want to guarantee that I'm not going to have a memory access problem, or I may want to make sure I don't have a threading problem, I want to have a case of where if I have an object that I'm referring to, I know it's always valid, that I'm not going to have some dangling pointer that's going to try to call this thing after it's gone away. or I'm not going to have a memory leak where it'll be hanging out there after it's supposed to be gone, or have a case of where I'm going to have threads try to access it to mutate its contents at the same time. So it's, like capture the flag, I have to say, make sure that only one thing at a time can have immutable access to the variable. If it's read-only, everyone can share it, but if I'm going to be mutating it, only one can only have it at a time. So here, this word move is a syntax keyword saying that, okay, I'm going to do a closure here where when I'm capturing X, I am transferring ownership of X into that closure. That means it owns it, its lifetime is controlled by that closure, no one else can access that. Even though it appears to be in scope here, what's going to happen, do you think, when I try to do print line here and refer to X? If I'm not allowed to access that because I gave it to the closure, bad things should happen, and those bad things will happen at compile time. So in comparison, here, where I said let y equal vector, and I do something there, okay, that should be able to work, but I can't access that. So if I go and I do what the compiler is, this is what cargo run will spit out. Note now, this is one thing I like about the Rust compiler, that if you screw up, it tries to tell you what went wrong. If I compare this to my C++ days, I was a big fan of using the STL, the standard template library, because I was doing a lot of algorithm work and it was great to abstract things. But when that thing went wrong, you had like 30 pages of incomprehensible gobbledygook that you try to go through and try to figure out what it is. So compared to that, I love what this says. And this says, oh, I'm sorry, Dave, I can't do that because there's a move here that you define that this vector does not implement the copy trait. Well, what does that mean? Well, since I referred to that, if vector implemented the copy trait and things which are just ordinary structures, like an integer, that's automatic to have that. That means that, okay, I really had to grab onto that thing. If it implemented the copy trait, I would just copy the value, just made a clone, just made an exact binary copy of that and use that instead. But since that object doesn't implement and tell me how to make a copy of itself, I have to grab onto the real thing. I can't let anyone touch it at that time anymore. And so therefore it's telling me that in line 4, it moved it, ownership. So therefore in line 6, the problem is that I moved the value that was borrowed in the closure is now being used afterwards, and that's a bad thing. So it says, sorry, I can't do that. Abort. This code will not compile in the first place. Other languages may potentially allow me to do things like this, which means that maybe it would work, maybe it won't work. But the borrow checker in Rust is there to guarantee that it will always work. That, okay, maybe you're smarter than the borrow checker, or maybe you can write some unsafe code that can be okay most of the time, but the point of the compiler is, hey, if the borrow checker says it's okay, it's because it's proved to itself that it's okay. And that's a nice safety guarantee that I like because I don't like chasing down bugs in production. So, why do I use closures? Well, my code is mostly algorithm stuff. And I really like the strategy pattern in design because the algorithm that I choose to use, even if I have a processing pipeline, the algorithm that I choose to use at different stages may need to be different based upon the type of data or what works well or change things in the future. And I realized that in declaring things and trying to do things very much like I did in C# before, just having an interface there, I realized that, well, actually, if at the top level I'm calling this thing to do something, what happens underneath below that to me is something where it doesn't really matter so much to the outside user how I put all these things to get there. And closures have a nice trait where it's easy for me to combine them and link them up together. So if I have a pipeline that's got 5 stages to it, I can define a closure that can wrap all those 5 closures together and give me one thing back that I can then, in this builder type pattern, send back to the top level and say, hey, here's this closure, just give it the data, call it. It calls all the pipeline below and returns you want. You can be blind to that. You don't need to worry about that. That's just fine. At the top level seems nice and simple. And I found I was doing fewer lines of code doing it this way. So let me show you some macro magic here. I talked about how I like to combine closures. So in my pipeline, I had to do step A and step B and step C and step D, and the types might change. I might have a vector that gets changed to an integer, which gets changed to something else down the pipeline. How do I call these together? If I had, in a lot of places in Rust or other languages, you may used to say, okay, A dot function dot B dot 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 dot, but that requires you, that violates the law of Demeter. You know all the way down the pipeline what all these things are. So how do I zip? How do I combine closures together? So this is a macro called compose. Now, I must admit, I found someone who had written a macro called compose before, but it did so with only FN types, immutable reference types. I, in my stuff, have to do things where I have to maintain state, so I need mutable references, so I can maintain that state and mutate over time. So I created a mutable version of this. Let's go with this language syntax here is. This macro is a template here which says, well, I have something, anytime you see an apostrophe in Rust, that refers to a lifetime. What are lifetimes? Well, to make sure things aren't freed prematurely or too late, we need to make sure we know how long things live around. Because I want to make sure that no one can call, the compiler wants to make sure no one can call an object after it's been freed up. No dangling pointers allowed here. So anything with an apostrophe refers to a lifetime, and the variable and you name it, doesn't matter, just use a letter, it's fine. So I'm calling it A. I have a lifetime A, and I have the following types that I'm calling A, B, C, G, and F. And I'm saying that all those things share the same lifetime. That means they will all exist for the same amount of time as far as what this thing has to worry about. And I'm going to do something with this that says, okay, I'm going to create a closure here. There's that whole box time logic again, except I'm doing it with the function mute trait. And what I'm saying here, I'm saying what I want to do here is that I'm going to have a type A coming in, and I'm going to have a type C coming out, which also has the same lifetime. So all these things are going to live the same amount of time. I'm saying compiler, make sure that nothing's going to get freed prematurely on this. All these, when I zip these things up, everything has to live the same amount of time. And send is a keyword that talks about, yes, I'm allowed to put this thing into a multi-threaded context. I can send this away to a thread to go off and do something. Okay, so where what? Well, type F, I'm saying what type F is. Type F has that same lifetime A, and I'm going to have, basically, this is saying I have a closure which takes type A and returns a type B, and that type B can be called by this other thing G and return a type C. And what am I really doing here? The magic comes down here saying, oh, in this box, in this box new move thing, it means simply I'm going to call F, the function F first, the closure F first, and whatever comes back, I'm going to call G on it. Has anyone here written in Lisp before? And you have to do parentheses and have to go right to left? So in here, I'm taking care of the right to left inside of this thing, so I don't have to do it that way. I can just click one thing that does all this. Now, that is a template which allows me to say, that tells me how to take two closures and zip them together. F and G, make sure F is called first, G is called on the result of F. But what if I want to have 6 things, or 8 things, or 12 things? One approach might be, I might say, I want to have an array of these things go in. But this is very much like the printf in C++ or C, or the print line macro in Rust, where at compile time you know you have things of different types, and you have a different number of them. And the way Rust chooses to handle variable number of arguments is through macros, which means that compile time is going to write code to take your variable number of arguments and create an exact function that takes that number of arguments to do what you want it to do. Okay, so who here has written a macro before?
Just very basic.
Okay, there are different types of macros. This is one of the simpler types of macros, so I was able to fit my brain around it. Macro rules. Well, what does this do? Macro rule says, okay, I can have a series of expressions. I could have many of these things. I could have not just 2 things I want to compose. I might have 6 things I wish to compose. What's going to do here? Well, it basically is going to imagine if I have a list. It's going to take the first, it's going to take one thing off that list at a time and call it, and then wrap the next thing around it, like a snake eating a smaller snake, or fish eating the smaller fish, and all the way down. So this is basically going to do a whole series of saying, I'm going to call this compose mute thing as many times as I need to. So let's think, if I had 3 closures I was trying to zip together, it's going to call, and let's say A, B, and C. It's going to take 2 of those and call compose mute and get me back a closure, which is then going to take C and then call that and add that together and do that as many times as it can. If you're worried about, well, wait a minute, I'm going to be creating a whole bunch of closures here and create a whole bunch of pointers and references at a time like that, is this going to create a lot of overhead for me? And in my code, no, this all runs very, very fast. I can't measure the time difference of doing this to what I was doing before. But that allows me to do, let's see.
What are the sized and send words in there for? I'm not following that.
Send means I can send this thing to a thread. Size means the size of the thing is known at compile time. So the type that I'm sending in or returning here basically means I can pass it on the stack and return it on the stack. That's important. Yes?
If I'm understanding that bottom part, right, so it looks very functional programming style, where like
Yes.
you're defining, okay, it could be this or it could be this, and then you're matching based on which one it is. Is that right? Am I reading that right? Where like, okay, if there is more, so I'm just reading your comments there, and so yeah, if it's a single argument, it's running that first one, and if for everyone other than that, it's doing the head-tail thing going on.
Think of it like the match thing in Rust, where I have the different cases that I'm matching up against. It's that logic, it's that
exactly.
syntax.
So
Yes.
kind of polymorphic style,
Yeah.
kind of a. But my question was, so head and tail, are those like? So is that part of the language, like, or like are those keywords? Like, where are these things coming from?
In your macro.
Inside the macro.
So those are variables.
Those are variables. Okay.
Those are variables. They're not keywords to the language. But it is if you think of
But an
Haskell and stuff like that,
expression
that expression I'm making
Then you said
clear.
it's an expression. The expression
Yes.
is the keyword there.
Yes, the expression is a keyword, and I'm saying I have this list that I'm chopping up into a head and a tail. And I'm working my way down, calling this thing with one thing at a time and splitting between head and tail and going all the way down that way.
Gotcha. I've
So
read a macro before, so I was just trying to understand that syntax, what was going on there.
Yeah.
And this is macro-specific syntax.
This is macro-specific syntax. So
Specifically
Rust,
macro rules, so declarative macros.
yes, not procedural macros. I haven't figured those out yet.
They're really,
Declarative
They
macros.
are.
I have not done it.
Declarative-
And there's like that whole what's that plus parenthesis function like.
Yeah, it means that I'm basically calling compose mute with this thing every single time, wrapping it all up. So I must admit, I took this from the compose non-mutable version and made a mutable version of this. So, this is why I dared work with this thing. But I think of it as a functional program that I've done before. I'm just simply splitting this up and going down the list of arguments and calling it recursive, calling it
It's just
repeatedly.
recursing right there.
Recursing all the way down until I have something which is turtles all the way down, calling all these things. But at the very end, I'm going to get one closure back. But when I call that closure, in series, it's going to call everything all the way down, pass everything down, and then result pass it back up.
That's a lot neater than actually, writing that out and changing it every time you change your process. So.
Yeah. So, so I don't, that saves me from in the real code when I compose these, I don't have to call the dots, or I don't have to do all the pipes like I would in F# or Haskell or do some of these other things. So let's just show some examples of where I use this thing. So this print may be a little bit small. Unfortunately, I can't use my mouse. Is there a laser thing on here?
Might be a little trigger thing on the bottom.
I think if you point at it, it has actually, if you point it at
This
the
guy
screen.
might. Nope.
No? Okay. So call your attention to the very bottom of the code there. Okay? Oh,
Like that.
oh, you did something.
Yeah.
I don't know what you did.
It's connected to the TV.
So at the very bottom
You
here
can see that.
of this code, you see compose mute, F and G. I have two closures, F and G, that what's really going on here, in my code, I have a processing pipeline that has a lot of steps. And because people don't necessarily make up their mind, that at a certain step, there are two different proposed ways to how to smooth this data at the end. A simple way, which had a few steps, and a very complex, more sophisticated algorithm had a lot of steps. And because that more sophisticated one required additional validation and we're busy, the requirements came to me to say, implement both, compute both, and we'll compare them over time and see which one we like and eventually make decisions at some point in the future. So my processing pipeline is doing all this stuff. In the very end, I have to call two different algorithms on my original data and keep both things around to compare in the future. So in this one, I have F and G, which are closures, and I want to combine them together. So this thing, which is called, this variable is post-dip smooth. That is a member variable, is a closure. Say, hey, I'm defining a closure here, which in this case, basically is saying what this is, that I'm going to do, well, to explain exactly what the code is doing, I have a time series of data coming through. Who here has ever used a median of 3 filter on time series data? Okay, so I want to despike this data. There could be huge outliers every once in a while, and a median 3 filter means I have a little window around the data point I have of interest. I capture with a little lag the data, so I have the time the data's gone before me and some a little bit after me, and I say I'm going to take that neighborhood window and I'm going to say that data point in the middle, I'm going to make it the median of that window. So that works very well to eliminate huge outliers. Okay. But then, I want to smooth this thing. So I have another thing on there called boxcar averaging, which is like a moving average of the data after that point. So I want to despike it and then apply a moving average. And I want to do it in that order. How do I do that? Well, I define a closure that does the despiking. I define a closure that does the moving average. And I use compose mute F and G to put those together. It returns a closure, which is my post-dip smooth thing. So when I call that, it's going to take my data, and under the hood, it's going to do the median 3 filter, the moving average, and return the result back to me. Now, here is the other algorithm that was proposed to me. So there's something that's called adaptive filtering, much more complicated. I won't go into what the math out is, but it's got a lot more variables, a lot more steps, a lot more stuff going on. So in that algorithm to do it, it also starts with a median of 3 filter at the top, but then I have these other things, F, G, H, and K. So I've got 4 things that this thing has to do to process this data through the end. So I define 4 closures as temporarily in there. I use compose mute macro, and that's going to zip up all these things and return one closure back to this member variable post-dip smooth 2, so that I say, okay, when I call this thing with my data, under the hood, it's going to call F and then G. It's going to call F and take that result and pass that into G, and take that result and pass that into H, and take that result and pass it into K, and take that result and return it back up the call stack to me. So when I call these things in my code, this is what it looks like. So here is self is when you're referring. When you're inside your class and you're referring to the class itself, it's like the this pointer for JavaScript or for C++ and other places. So I have an object where I said I've got this member variable post-bit smooth, which is that one composed series of closures. The other member variable is the alternate one, which has a more complicated set of pipeline. They're both closures. And the way I call them is simply I'm saying, okay, I am passing data into it. In this case, you don't need to know what dipx is. It's just a variable, but I'm passing data into it, and I just call it like I'm just dereferencing it and saying I'm dereferencing my closure, passing the data in, get my answer back out. So the person reading my code at this point says, oh, I can tell I'm doing something to smooth this thing, and I know they're not the same thing, but I don't need to know all the details of all the algorithms and all the things, and I don't have to give names to all these things. You look at the original code up here. Yes, you can see names and things like there to talk about what algorithms I'm referring to, but there's nothing up. I'm not getting anything out of value up here by declaring an extra step with smooth or something on that. It's just going directly to calling that. Now, why do I do this mutable? Well, the example I gave of where like the median of 3 moving average, every single time a new data point comes into me, I have to memorize what that was and keep track of it, as well as a moving window of the last n number of data points, and I have to update that ring of data as I go around. So every time I get called, I have to update the internal state and mutate it. So I just can't do this with with immutable reference, I have to do with mutable data. And now you think of it, who here is called, what's the lovely library that allows you to do things in parallel?
Rayon?
Rayon, thank you. So in my data, what's going on is I have 200 megabytes a second of images coming into me. What's really going on is there's 432 locations that image that I care about to analyze. So I'm able to set up, off that same data set, I'm able to set up 432 things in parallel to go analyze each their own little section of the image and do the processing they need to do. Now, we don't have 432 processors in our machine, but with Rayon, I can say, Rayon, go do your magic here, and Rayon will do all the work necessary to carve it up and share it on processors and do what I need to do. Well, Rayon, in order to do that, needs to have some guarantees that it's safe for it to take things in, it's going to multitask and put things around. Because the way I define these closures with send and size, it knows that it can do this all in parallel perfectly safe. So every time I call this thing under the hood, I'm doing things massively in parallel here. And it all works relatively fast. The amount of time this takes me to process is every time I receive data in of the size of, let's see, about 75 megabytes chunks at a time, it takes me, 1 to 200 milliseconds to pass it in. So all the closures and the overhead extra pointers and vtable stuff I put in there compared to the 100 milliseconds of computation time I have, it's nothing. It's microseconds for the overhead of the closure. It's milliseconds for everything else that I'm doing. And higher up in this thing, you can see other cases of where each of my step like this pre-dip processing midway down, I'm declaring closures and just returning one thing at a time. It's like I'm declaring the closure there and returning it. I only compose mute if I have to do multiple of them put together. Now this is all very theoretical, so what I like doing is I like using...
Can I pause you for just a second?
Oh.
I'm going to see, for some reason, the video stopped over here.
Oops.
Oh, it just killed it forever. Alright, so you're...
So I was about to switch over to the Rust Playground. Who here has used the Rust Playground before? Okay, about half of you.
Give me one more second.
The Rust Playground is wonderful because the Rust Playground, it's really, if you think of it, if you're going to write a website that anyone can come and use, it's got some rules on it. It really just allocates one thread to do whatever you're going to do. And it has a timeout, so if your thing takes too long, it's going to abort itself and then say, you can't do that, Dave. But it's a very nice way for you to just quickly throw some code in there and play with stuff, and the compiling happens on the server and gives you the result back. So let's play some closures here.
We're back to our problem of the TV not wanting to show what the stream shows.
Uh-oh, we lost our screen. How did you do it before?
Does anybody remember what the sequence was? It was
Started with power, and then
okay, so was it out and then in, or was it in and then out?
It was in and out.
In and out. I just remember you saying, I
But it's
unplug this and
possible
plug
when
this
you-
back.
well, there are only
This
so
and
many
plug this back
combinations.
in. So,
Okay,
I don't think that's
take it
right.
apart and do it the other way.
All right, let's take it apart and do it the other way. Okay, we're gonna unplug everything, and then we'll plug in this, and then we'll plug in this, and then we'll plug in this. It's showing up on the stream. It's just not going through to the TV.
Well, it took it a minute the first time.
No,
It's that,
yeah, I see it on the stream.
What, did you document what you did before?
you said power in, then out.
All right, first we'll plug in the power. We'll wait 5 seconds. 1, 2, 3, 4, 5. We'll plug in, and then we'll wait and we'll plug in out. It's on the stream.
Well, what order did you plug? That's the power thing you said, so.
Now,
Let's try it one more time. Maybe
Maybe
it's about the speed that you plug it in. Maybe I plug it in really quickly like that.
think just having them plugged in and then repowering it would do the job.
Saying,
Can we just
Can I just
put
plug,
the stream on the TVs?
can you point out the screens at this point?
That's what I'll do. All right.
Okay, so give me the gray cable.
Okay, we'll do a swappy deal.
Okay,
Cross-compile or cross-package.
Well, I've heard some basic issues about like Mac itself. It's incredibly fast and works awesome, except it's obvious that Mac OS software-wise has a little bit of bugginess around the new Macs.
Could it be that this needs something done to it?
All kinds of crashes.
Okay, so
now this is stop working.
Do we need to,
What?
It was just green for like a while, like for about.
Now this isn't working.
And then shuts off. And I'm like, oh, I gotta go to the house. And then I turned it on.
Oh, something's happening.
It just started not working. I was like,
Something's
I was
happening?
terrified. I was like, oh crap, like,
Well,
I just
the
lived on
TV
all
is
these
on
nights
now.
and like contracting, and I'm like, I can't just charge for my machine down. So.
HDMI, the best invention since the guillotine. If only there was a way to control displays so that we know that you can't get information through, but sometimes on an authorized device with HDCP and HDMI, all of the right standard with all the right devices connected, you might be able to get a display.
is anybody know what you're supposed to do with this to get it to go?
By the way,
Just try
Daryl,
unplugging your laptop and plugging it back in again. I mean, it worked before. Would we do it 20 times and then it just not worked?
But how will we guarantee DRM through the chain?
Someone might copy a movie. You wouldn't
God
download
forbid.
a movie.
It worked
What we
originally.
have now is blocking it 100%.
So did we touch anything on here?
I just
Can't
restarted
steal
it.
it.
You can't steal a movie. You wouldn't download a movie. You wouldn't download
Should I restart my laptop?
You wouldn't do that.
Okay, so now
I
this
give you the chest of gold.
You
I
wouldn't
give
steal
you
a
the
gun.
key to the chest
Got
of
it.
gold.
I'm restarting my laptop.
But you're only allowed to open it when I say. I start 1,000 different
Things are
services that
beeping
also
here.
offer.
Hey, now
very
this thing's
painful-
blinking.
What do you do?
So the lesson here is when it works,
Put back my
don't touch it.
I put my pirate hat back on is the answer.
it's
Not that I would ever do that.
anyway, right?
Not that anyone would ever start their own home server with
Just saying.
several terabytes.
Well, we had all these channels from like cable providers and like, oh, that's a pain, why don't we have all for the Netflix? And Disney.
Why are we
And
going-
HBO.
But then Netflix made money and they were like,
Why is it doing something with Teams?
Yeah, that's what I'm wondering.
It's because you're messing with the
It's-
console
it's-
thing. Did you touch anything on there?
Well, I had hit the display thing. I actually restarted the display because it was frozen, so.
Okay, just leave it.
Yeah, hopefully it'll come up in a state
Just-
where you just attach now.
Okay,
I fixed it.
I restarted my laptop and it's communicating now.
So it was Windows the whole time. I knew it.
I was gonna say, I mean, it's your operating system, except that this is all Teams, so like, if anything was gonna work with Teams, it'd be Windows.
oh.
Have you ever watched a Microsoft presentation on stage?
No,
Oh, what is this about?
Factory reset your laptop apparently.
You know, I went through a Windows update yesterday.
You in
My
The Windows
goodness.
update harder.
I have a dual boot system. I'm in Linux most of the time.
Reformatting your drives.
Okay, fine,
Windows
done.
always freeze when you're presenting.
Okay.
Setting your drive to be sensitive.
Wait, 4K video downloader? I thought you said we weren't gonna download movies illegally.
Okay.
Yeah.
Rust Playground.
it's not my laptop.
Okay.
Didn't know how that happened.
So here's the Rust Playground where, let's see. Oh,
Must have part of the Windows update.
Windows update, put it there.
let's
Oh.
comment some of this stuff out for now. No, I don't need all this stuff to come up here. And everything is coming back up. No, I don't need Discord.
Where's Clippy? You think you don't need Discord, but you do.
Spotify will be joining in a
Okay,
second.
my Discord started.
Now my Teams is coming up. Okay,
I
so
want it to, it doesn't.
this thing is just a simple place so I can put some code in here and hit run. Is this working? Yes, it's working here. Okay, so let's look at this thing here. So let's see what we learned about closures here. This first closure I'm calling add C. So box is that smart pointer container that we talked about before. And new is a method on box saying, hey, I'm initializing a new smart pointer here. And the syntax here for the closure is the arguments going into the closure, they don't use parentheses here. They use the bars to say, hey, these are the arguments going into the closure. So I have an argument that I'm referring to as x coming in. And I am going to, just for fun here, I'm going to use a print line statement here so the value prints out to know what it is coming in. And I'm going to return the value of x plus c. And c was defined external to my closure, but it's going to capture that. That closure is going to capture it.
So just to understand, so the box, that's supposed to be like a pointer to the heap, right?
So the box is a structure that's on the stack that internal to that structure has a pointer to somewhere on the heap where my closure is.
And so and by you passing in this function, is that the like what is it putting on the heap exactly? Is it the function? Like
Think of it as an anonymous class that's got code for the math that I'm doing and for the variables that's referring to. And
so there's all of that.
all
what's
that is
there?
somewhere on the
Okay,
heap,
okay.
and the pointer to that thing is inside this box here.
Gotcha. Yeah, I just wasn't sure what it was putting out there, but just
Okay.
everything in that function. Got it.
So yeah, the code out there that knows how to call the print statement and knows how to do math is going to do that. So I've defined this anonymous class out there that has just those variables stored in the code. Now here's another one, D, which I say multiply D. What's it going to do? It's going to take something comes in, it's going to print out the value, and this time, I'm going to take x and multiply this value of D that was defined elsewhere. Okay, what about this thing here? E, divide E. Well, what could that be? Well, it's the same thing. It's a closure that's going to print out the value of the argument coming in, and then it's going to divide it by this value of E and return that back out. And then using this compose mute thing that I showed you before that scrolled off the top of the screen here, I'm going to compose these things all together and see what happens. Okay, so what do we predict? So I'm defining, okay, now here I'm saying net is going to be the result of all these closures together. If I call net with a value of 1, what do we expect will happen? Well, which subclosure will be called first?
Molt D.
So because I said molt D, add C, divide E, yes, it's going to call multiply, even though I defined it this way, purposely the order, it's going to call multiply D first. So it should print out the value of 1, right? Mm-hmm. And then it will divide by D, which is 3. Okay? So what's the next thing that's going to get called? Add C.
So plus 4, so it'll be 7.
So it'll take the value coming into it is 3, and it's going to add C to it. Okay, that'll make it 5. Well, let's just run it.
But that,
Okay. So 1 came in first. So the value of 1 went into multiply D. Multiply D multiplied by 3 and returned 3. 3 then went into the add function. That's why 3 got printed out and added 2 to it, which made it 5. And then divided by E happened, which divided by 4, I get 1.25. So all the print lines weren't necessary. It was just to trace my stuff all the way through here. So, this is, okay, great. Well, why, in this case, I really didn't have to have a functional version a mutable version of this because all this stuff was constant. So let's do something a bit more fun down here. So let's suppose that I really do need to keep track of some state over time and that state's going to change. So I've defined here some values, min and max. What's the minimum floating point value? What's the maximum floating point value? Why? because we're going to keep track of the min and max values as we go through this data I'm going to feed through this thing, because for some reason it's important we keep track of this. So I've declared this thing called average value is equal to 0, max min. So fmin, what is this thing going to do here? What it's going to do is that it's going to say, I'm going to compare this against the minimum, I have this minimum value. I'm going to compare against minimum value, and a minimum value is different. I'm going to say, whatever the minimum value between what you pass into me, what I had already, I'm going to compare that, I'm going to store that result, and I'm going to return that result back. So I'm doing two things. I'm returning to you the minimum value, the running minimum value, but I'm keeping track of that internal to my closure every single time. So in the previous example, if I call those closures over and over again with the same arguments, I get the same results out. In this case, I have some state here, so it's going to be different when I call it, even the same arguments here. So the next one, fmax, what's it going to do? Same thing. It's going to say, I'm going to compare what you gave me to what I have internally, return the maximum value, and store that max value to use the next time we go around on this thing. Average, what do you think average is going to do? For some strange reason, I think I have this requirement that says, whatever value given to me, take that and compute the average of it with the variable you had from the last time, for whatever reason. Maybe this is some sort of weird smoothing algorithm, who knows. So I put this together and says, okay, fmin, fmax, average, that says, okay, what I want to do is I'm going to say, calculate your running minimum of something, return that result, put it through your running maximum function, return that result, and now send it through your average function. So now I have these two closures down here. So I'm going to call this net version 2 with the value of 1.0. I'm going to call it with the same argument. Do you expect to get the same answer out the second time? I called net 2 here on line 58. If it did, I'd be surprised. Yeah, I made it complicated on purpose. I should not get the same answer. I've got mutable state, and let's see what happens here. So let's run this. Oh, here's our old friend here. Okay, it did this. Now the first time I went through, the value was 1. Okay, so since it's the first time I called it, 1 is both my min and my max. Okay, and then, however, my running average is now 0.5 because I initialized this thing with 0 internally. So the next time I call this, what's going to happen now? Well, now what's going to end up happening is that it's going to compare these things, but when it goes through, it says, oh, I'm now going to take 1 and average it with 0.5 and get 0.75. So even though I call it the same thing, I get I get a different result out the back end. Now, is this useful? In this silly example, no. But it shows that I can have mutable state here. And if for some reason, if I had a whole, let's suppose I had a whole array of values that I need to compute this weird thing on at the same time. I could call those things all in parallel, and I would know that everything works just fine. Even though I have mutable state here, the compiler would know to make sure that that mutable state is properly packaged in the thread to do the computation it needs to know, and would not get accessed by more than one thread at the same time. Everything works just fine. So I like Rust because even though the syntax is a bit more complicated, I'm able to do things that more functional type programming languages are able to give me, but I can do it in a lot less memory and in faster computational time and more deterministic functionality. You know, in the stuff that I do, I can't afford the garbage collector to go away for a second or two and then come back. You know, I need to have more predictable behavior, how the memory allocation is working in this, and Rust gives me that. Yes?
I'm just curious, so you're referencing min value in the fmin function, but it's not a move closure, and for some reason I would have thought that it would need to be, but it obviously doesn't. Can you help me understand the reason for that?
Which line are you referring to?
So we have the fmin on line 42, right?
Mm-hmm.
The closure, it's not a move closure, but you're still referencing min value, and it is mutating it over time. I don't know, something about that I'm not understanding.
Well, let's
Getting a mutable reference.
see what happens if I say move.
In the closure, a mutable reference?
So this closure is going to be an FN mute like type closure where
Mhm.
you can capture it by reference, a mutable reference.
So in this case, I'm now saying move on all these closures, where I'm transferring ownership to this.
Yeah.
Now, extra credit here. What's the type of X? What's the type on X?
There's that.
In each of these closures, did I ever define what the type of X was?
Well, F64.
When I wrote the closure, I did not. But the compiler looked to when I called it and saw I called it with the floating point number and then inferred the types all the way through and said everything's kosher, everything's fine, I can do that just fine. Now, simple value types in Rust knows how to copy those things. So because before I didn't say move these things, I didn't.
Because it implements copies.
Yeah. So,
Oh.
and now that I put move on here, it does take ownership of those things. But what's really happening in the hood is it's making a copy of those floating point numbers that went.
If these were more complex types that didn't implement copy, we would want to do move in that instance. So that's what I was trying.
Yeah.
Cool.
Yeah. So if I had done this with with a vector, and maybe the math inside were a vector or something instead. This was not a template that I did. This was not a generic. It's just type inference made it all the way through and knew what I should have called these things. But the move here, I would have to do the move here if I said I want this thing to take ownership of this. And that would be very important to me because if I did try to do something multi-threaded here, I would need to move it because I'd have to move ownership of the argument into the thread that is going to go process it.
Can you wrap one of those in just like a tuple struct or something, just to show that?
Wrap what?
Let's
So
say like
we're
min
creating
value.
structs implicitly with a single function, right? That's what the closure is.
No, I'm saying wrap
Is that what
min
you're
value in a little struct so that it's no longer just a pod type that implements copy.
Okay, let's say min value.
What's that?
I want to throw that signature that you talked about earlier, where it's like,
Well, yeah, it's just-
copy.
Oh, what did I just do here? Okay, so let's try this. Let's declare vec zero. Help me with my syntax here. Does that work?
Yep.
Does that work?
Semicolon.
That looks right to me.
Okay. Okay.
You might need to put an F64 on the end of it though.
Let's find out what it infers.
Yeah, okay.
Let's find out.
Actually, you don't need to. It's only if you really want an F64.
And
Maybe that main function.
so let's do this.
And then if we remove the move, we should get some kind of error, I assume, if we just did it on one of the closures.
And let's do that. And let's do that. Okay, now we have a size 1 vector. Let's see if this compiles. Okay, it worked. Okay, it ran. But now, what is the next thing you wanted to do here?
On line 42, if we remove the move.
Get rid of move.
Yeah. We could do it all to the moves, but I think one will show the cases.
So all the move does is what move does is says I'm taking ownership of this thing, and since copy is not defined for a vector, it means I can't refer to it. So let's do this.
So refer to it afterwards.
Yeah. So let's do this here. Let's say I put in the value of, let's see.
What if you just do another compose mute at the bottom?
So if I were to do something here of print line.
Something that tries to take ownership.
Let's see. And then I want to print out max value
You need an exclamation point.
or min value. And I need, okay, that's Java. I need this, right?
And a semicolon.
Semicolons, love them forever. Let's try running this.
There we go.
Oh, what happened here? Cannot borrow min value as immutable because it's also borrowed immutably by the closure. Can't do it.
So what's the type of value in the closure? Is it a mutable reference specifically? What's the type of min value in the closure? Is it a mutable reference?
So when I define my macro for composing, I said that all these closures had the FM mute type. So I said that I'm going to borrow everything mutably from that environment. So when it took X into it, it took it as with a mutable reference.
Yeah, but outside of the closure, that max value it's not a reference, it is an owned vec, right? And inside of the closure, you're referencing it the same way, but it's being referenced, but it's not a reference. Is that not the type of min value in the closure? Sorry, this is tripping me up, and it should be.
The closure's capturing it by mutable reference because the compose mute function
Yes.
defined FM mute.
Yeah,
as the type of
I understand that. It's just in the function, I would expect the type signature of min value to be not the same as the type signature outside the closure, because one's a reference and one's not.
I don't see any type signature of min value inside the closure.
Well, no, yeah, because it's inferred, but what the type signature would be. Right, so the type signature of min value is?
In the closure, it would be a mutable reference.
Yeah, which is different from outside the closure, that's the case, that's just what I'm asking.
Oh,
Is because it's different implicitly, which
So-
is interesting to me.
So when it says it moved, because it could not automatically copy this thing, the rule is if I've transferred ownership of this thing and it could not be copied, which it can't,
To take a reference.
no one is allowed to refer to it all. Is the rule that it does. If I have transferred complete ownership as if the thing doesn't exist anymore for the code.
Yeah, that I understand. The thing I don't understand is, I do understand, I'm just checking if it's correct, because it seems odd to me that the signature of min value in the closure would be implicitly different than the type signature outside of the closure for min value. Does that make sense? If you were to go after min value and write an explicit type,
You want me to define this as F64 or something? Is what you mean by defining a specific type, or?
no. So on line 40,
Well, line 40.
go ahead and after min value, vec F64.
So this is going to be vec F64.
Yeah, or I guess it could have been F32, but this is what it already was, right?
Yeah.
So it inferred that type. But inside of the closure on line 44, my understanding is that variable is no longer just a vec of F64s, it's a mutable reference to a vec.
But they're two different variables. One happens to be a borrow to the other.
Yeah, but it's just implicit, right? So it's not very clear, is I guess what trips me up.
So this max value here, or min value here, in either case, even though I declared it out here, the closure essentially said as though I had declared it internal to the closure as a member variable to a class. The way this
Well,
syntax.
not really, because it's you're not accessing like dot this and referencing it as just a vec. It is being referenced from a mutable reference.
But it was
So it
declared,
is
it's
different.
declared mutable up there. Mute min value equals vec.
So what this closure actually did, it said, okay, I see in this closure a person's referring to something which is min value.
Yeah.
Okay.
Yeah, no, I understand. I think we're dancing around each other at this point.
Okay. But it's a simple rule that says that, hey, I'm making this private to this class, this anonymous class I'm creating, and not allowing anyone else to refer to it from anywhere else after that point.
Yeah, I understand the ownership semantics.
Okay.
So, right, I think, does it make sense to the distinction I'm trying to make, or is?
Are you
not-
saying it's just hard to know a priori just based on looking at the closure?
I get, my confusion is you're asking about the type changing, and I'm thinking, well, this is an issue about the borrow checker saying who owns
No,
that
he's just
thing.
talking about the types changing from
Yeah.
inside and outside.
It's just interesting that the type signature implicitly changes inside of that. Right, the min value, like what you said, it's
Mhm.
almost like it's a different variable, really, in that it's a mutable reference.
It
And
is
outside of the closure, it's not a mutable
It
reference.
is
that
a
is
different variable.
Yeah,
It
that's
really is a different variable.
Yeah.
It's just,
Yeah,
Except for
it's
it's
just
the same
because-
name, you
But
didn't
it's the same
declare
name,
it, so.
you did declare specifically inside the closure, it's just very implicit in its behavior, right? And that it does that, which is
Well,
interesting.
knowing that you're mutating it, I agree, it's a little bit like.
Well, yeah, it just wouldn't be exactly like super obvious to me based on the syntax that that's the exact nuance of what's happening.
But the only way you could do that is if you're either moving it in or it's immutable reference,
Yeah.
right? So
Yeah,
if
yeah,
it's
yeah.
not a move, you know it's immutable.
So obviously it makes sense, it was just
Right.
me realizing, connecting all the dots, yeah.
Okay.
I
So
have a
here,
question.
I took away the mute here on purpose to show that it's now complaining that when I refer to it on line 44, it says, I'm not allowed to change that thing.
Yeah.
Because I'm no longer finding it as
mutability
mutable.
and more the reference,
Okay.
right? That's
Someone else was raising their hand.
So at the beginning of this, you described 3 types of closures, and I guess, or you functions, right? Are those, for lack of a better term, are they like primitive types? Like they don't, coming from like a
So-
Java mindset.
so the
like,
th-
if they're
the-
like something they would extend or inherit. Or
So the 3 types of closures, the first one was just FN, which means I grab onto things with only immutable references only. These things up here could all have been declared as type FN,
Mhm.
because although referring to other variables, I'm never trying to change their values.
So I understood the
Yeah.
differences between the 3 of them. I guess
Yeah.
more generally, would it be possible to implement a macro to compose an arbitrary any type of these functions together, or not?
Well, in my macro, I had,
I understand you obviously yours is very straightforward because you're saying we're going to take one of these functions and compose them with the same type over and over and over again recursively. Right?
so if in my, this all started with some generic code, which I referred to in my macro. And in the generic code, it was knowing that the types I was passing into were doing different things. But if you could imagine that to do what you're talking about, if I had done something to allow to declare an extra type in those brackets to say what type was the closure, I think you could potentially try to do what you're talking about, but that would be a very messy thing to work with.
Okay, but it's not like a straightforward, like, oh, there's a super type that all of these things share behavior with, and you could do a basic.
There is actually.
There
Yeah,
is?
there's a
Yeah.
more complex type. Yeah, and I've got a question about that because I hit it back in December when I was trying to make kind of a thing with units. And I had a structure, and in the structure, I was grabbing a closure. And when I tried to use it, I was always getting these complex issues with the type. And I was looking at the type and I had these big, long, messy types that weren't matching with the usage. And I could never seem to get it to work. And I was going to ask you if that's kind of why you've got the box around the closures. Does that do something to help? Or?
The box is required to have a smart pointer around the closure. Since it's dynamic dispatch, I don't have something which sits on the stack. I have something on the heap, and so I have to use a box smart pointer to
Because
hold on
it's
to
not
that thing.
sized right. It's
Yeah.
Okay.
not.
So that would not have solved my issue then, because I was getting a type mismatch with the.
When dealing with dynamic dispatch stuff, I have no idea how big that thing is.
Yeah.
So I can hold the pointer on the stack. I can't hold the object on the stack, which is dynamic
So you have to
dispatch.
keep-
So I have to
keep
use a smart
allocating.
pointer to
Yeah.
keep track of it. And that's what box is.
For the FN mute, I think your question was kind of related. This is going back to something else because I found the documentation for it. But I think this is related to the difficulty I had with the small, like lowercase FN and uppercase FN, because the FN once, FN mutant, just capital FN are all traits that are implicitly implemented for different types of closures. And it turns out that the reason I haven't hit like the actual function pointer
Mhm.
is because typically you'll use the actual trait for function signatures, and function pointers do implicitly implement all three types of those traits,
Oh, that's.
which
So,
I didn't know.
yes, if, in this example here where these first things were really just fine with just fn, they really were of type fn, I was able to use them, well, these three closures I've highlighted right here, because I'm not mutating what C,
Yeah.
D, and E are, I could have defined them in with a composed thing that just required type fn.
Yeah.
But it worked with this because anything that's of type fn is able to be used as a type fn mute.
Yeah. Oh, and maybe that answers the question about which was the super type, because that like.
I mean, the terminology notwithstanding, right? But
Yeah.
Yeah.
So-
Anything that implements FN also implements FN mute and FN once. Right?
Yeah, so I don't need, it doesn't, so it wasn't mutable, but it could be treated as though it was mutable.
Yeah.
With the impact that that's going to do is that it means that at runtime, because that thing is being declared as mutable now, it's going to have an impact on who else can have access to that thing. I have exclusive ownership in this composition here. So it got promoted, if you will, but it got promoted to more restrictive usage.
Yeah.
I mean, you can't go the other direction. You can always be more restrictive.
Sure.
You can't get less restrictive.
I have a question going back to the error we had earlier with the print line.
Mm-hmm.
How do you fix that? So it's common. It's common. You might have an array of things that you're calculating, and then at the end you want to see the results. How do you fix that?
Okay, so let's see. We're now to the borrow thing here. Let's take this thing right here.
Yep.
Let's cut that out, and let's put that there and see if that fixes it.
Or you could, if you wanted to leave it there, you could return value from that function, right?
So in this case,
You're already setting it to something.
I was accessing the value, even though I didn't mutate it. I was accessing it before I defined my closure.
Which now has a mutable reference to it, and therefore nothing else.
But the compiler would say, hey, I mean, the rule is that once I have given ownership of this, the borrow checker says, once I have given ownership to something else because I have a mutable reference to it, hey, this thing has a mutable reference, it owns it, no one else can access it. Because remember that if I don't give immutable references to things at the same time I don't give immutable references to things where someone holds a mutable reference to it, because the value that these guys are going to see is unpredictable, because that thing over there could go change it on them in a way they don't understand. It's going to cause all sorts of weird threading bugs. So that's why it says, okay, I'm safe referring to this here, because there's no potential conflict for this, but then after that point where someone else is grabbing this mutably, it says, sorry, no one else can refer to that at all while someone else has a mutable reference to it.
I was just saying that if you wanted to leave your print statement there,
Mhm.
like down below, is there some way you could return the value from the closure, that vector back?
So
Does that make sense to like give it back to the
Yeah, right now you're putting
outer
out.
scope?
Here you're putting out before you've done anything to it, so it's kind of useless. I want to see the results at the
So
end.
you're saying if I were to do something like this after I'm all done,
Mhm.
oop, I somehow told it to compile. So if
Yeah,
I said, am I
exactly.
allowed to do something at the end when I'm all done
You
here?
have to return that min value somehow from that closure, because that's where the current ownership is.
Would you'd start needing to use what's like synchronization primitives, like an arc or a mutex to do what they're asking?
Wow.
Because you're specifically looking for, in your closure definition, the composed, right?
It seems like every closure, since you're composing them, would have to return it. Because you'd have to chain it all the way.
Yeah,
down.
you're right. Yeah, that'd be kind of a mess.
The playground is crashed. Okay, the playground is happy now. So if I go down here and I say print line and go in there to say
Which is a
parentheses,
very functional
this.
thing to do, by the way. It's just,
And then I say, what was the thing? It was min value. Okay, if I print this
That's why I have
here,
such fancy type systems to
Yeah,
make it
that's
so you
right.
can pass all this through.
Try to understand it a little easier.
okay, so here it's still complaining about it. My understanding of the value of fn once is if I had defined these closures as FN once, and I called those closures, the rule is I'm only allowed to call it once. So my understanding of the way the syntax would be, after I've called that closure once, it no longer owns those variables. I can transfer their ownership to someone else at that point. If you go into that German paper, he gives an example of that, I believe, of where you're doing a lot of calling of closures, but he's using they're using FN once. If it's not in there, it's something that he referenced into there. So I think that would work in the case if I used FN once
Do you know
here.
how you do that? How you transfer that ownership? Or
I
is
have
it
to
just-
I
or
have to
is it
look up
implicit, like that
I have to look at the example. This is the borrow checker says, okay, I had control of this, but once I called it, I have now released control of that, and that ownership can transfer to someone else.
That's cool.
That's cool.
Yeah.
It's just that I don't have use cases that use that, so I'm not too familiar with the syntax.
Yeah, I did
But
not
that's why
understand.
that's why there's three types. I own everything read only. I own everything mutably. I temporarily am owning something, so I can call it once
This
and then
one
give it
time,
away.
yeah.
I like that.
Yeah, I wondered what the FN once was for. I read something about it, and it didn't make sense. So, thank you.
So in that when I give up that ownership, it could be that no one's using it, so it automatically gets destroyed and goes away, like an iterator that's no longer needed. It can also be because you want to then have someone else refer to that. Okay, so this was fun for me. I got challenged in some things I hadn't thought of before while doing this. But message here is, when you're trying to just play with something without saying the rigmarole of a whole, you're reading something in code, reading a paper, you want to try that and play with it. Rust Playground is a nice little safe place to just try out a little few things. You're learning about the syntax of something works. And when it works, okay, create your project and paste the code in there. Closures are a very easy way, if you think of Lambda functions, anonymous functions, stuff like that. I think this is a way of doing something a bit more fancy, being more like an anonymous class. It is a single function you're defining, but rather like an anonymous function where you have to have everything defined in the code, you're allowed to get some context and variables, and if needed, you can have mutable references to that if you're using a closure. And with certainly the stuff that I'm doing where I'm trying to inject into my stuff, this is the code I want you to call at runtime rather than about how to put together all the algorithms and so forth. It's a great pattern. It works for me. And it works really, really fast. This compared to C# code, with the library, which you just said, I keep on forgetting the name of the thing, rayon, thank you. All I had to do is declare my iterators and just test it single-threaded, and once everything was working single-threaded, I just changed all the iters to par iter, and then everything ran multi-threaded just fine. And compared to C# code, it uses 1/3 the amount of memory because it's not got garbage hanging out there in its face and needs to be cleaned up. And the time delays to free up the memory, I don't really measure them because what's happening is as I'm using things up and I'm done with them, instantly Rust is cleaning up just like C++ would. So the time it takes to free everything up, well, one, is very, very fast because for garbage collector, you have to do this algorithm that says, let's go through all the objects that I have in memory and see if they're still needed or not. So that's a very expensive calculation to do. Takes a long time. With Rust, just like C#, it says it knows that, I know I'm done with this variable at this point. Don't need to go around and look, inspect anything else. I just know at this point I free the pointer and go on. So the memory deallocations are mirror allocations are very, very fast.
So I've got a question. Looking at FN once, FN, and FN mute, obviously under the hood they're traits, but they define a function, like say FN once defines a function called call once, right?
Mm-hmm.
And the reason you can call it once is because it takes self by value ownership, right? It takes ownership of self.
Mm-hmm.
But in this case, where you're just in the playground, in the main function,
Mm-hmm.
what does self refer to exactly? Is it generating a struct that just wraps those variables and that's self?
Self can refer to any struct.
I know, but in the specific case of a closure that's not in an info for some struct.
There is no self in a closure.
No, there is.
Not that you would be able to.
You're looking at,
You're
you're
not
look-
calling this directly, I know. but-
you're looking at the
also
library
notice
for how
that-
closures are implemented?
Well, just the traits.
Mhm.
Yeah, and you'll also notice that column one's, it's an experimental function, so it's not even something.
I have not looked into the library to see how they implemented it.
If you scroll down a little bit, that function, if you go look in the
But-
required metric.
But let's talk a little bit about what traits are.
Manually only.
Oh,
So
okay.
that's not actually coming out there.
So in some languages, if I want to implement an interface, I have to declare up front in my function in my class declaration that this thing extends this interface. Rust allows you to be a little bit more coy with that, to say, well, I've declared my structure with my member variables and so forth, but then underneath that, I can say, oh, I'm now going to implement this interface or trait on this structure. So whenever I'm dealing with a trait, because I'm always implementing it on a structure, I have to, I can use self when referring to that, even if the self is only a basic primitive type, like an int. That still is from the syntax point of view, it's just a very small structure.
Right. So, well, I guess what I'm saying is the syntax for Rust closures must be, under the hood, generating a structure that implements this trait. Is that?
Yes, it is creating, so everything that I'm capturing as a member variable has to go into that structure somehow.
Right.
And then the function that I'm calling, that function is I'm just guessing here, is probably creating a function somewhere and then having a pointer that's called by that as well. But yes, it's gathering all this up and creating a structure with the closure, yes.
Well, and the trait defines what function, the function type or definition at least, right?
Yeah, in the trait it says, oh, when I call this function, I'm going to be referring to these member variables. So when I'm calling min here, it says these things that I've captured, it builds the code necessary to refer to those things in the structure that it built.
Just a little magical.
It's
Fine line
it's
between
it's an
black
is an
magic.
automatic anonymous class
Yeah.
where it grabs the member variables from the environment by what you. So it took the code that you wrote and did all this rearranging under the hood to create this anonymous class for you.
It'd be interesting to see the code that it actually generates. Do you know if there's a way to see that?
I would just go into the library and just look up the implementation of FN, FM10, or FMU to see exactly what it's doing.
That's actually what I want to see was your macro, what it was producing, and then maybe some verbose form or the type. All the inferred types were
So
explicitly declared.
there are ways, I don't remember how.
I'm sure
Is that
there's
cargo
flags,
expand, I
yeah.
Yeah, something
Yes,
like that.
that you can tell it, please expand my macro for me. And it's interesting, I use the IntelliJ IDE, and when I load up my project, one of the things I notice it does is that it says expanding macros. So the IDE is actually expanding the macros for me, because what it's trying to do is it's trying to highlight my syntax errors and stuff like that. So the IDE is actually expanding the macro under the hood into what the real Rust code would be at runtime. It's not putting that into what you see. It's doing that behind the scenes so it can do a syntax checking to let you know if you screwed something up. But it takes it a while. When you open up a large project, you see the IDE is busy expanding all the macros for a while. And macros is one of the things that makes compilation from Rust slow.
Yeah.
Only
One of the things.
One of the things.
One of the things.
I was also curious, so you do it recursively, and I know macros have like a recursion limit by default, right? Have you ever hit that with your macro, or are you?
No.
Okay. I think it defaults to like 8 or something, I don't know. So you'd have to put probably 8 things into your macro, 8 closures in a row.
Let's try it.
Actually,
If I tried to put a line with 32,000 arguments, I would probably have a call heap stack collision something on that.
You can compose them like a tree.
But given that I'm running this out, the fact I would ever write anything with enough arguments to run into that limit is probably not something they worry about.
Is it small? 8's not that many.
no, I think for specifically macros, the recursion limit is like really unusually small.
So I have this recursion for this argument list I'm
So
passing
if you
in.
pass more than 8 closures into your chaining, I forget what you named your macro. but I think it
What's
would-
the maximum number of things can you print in the print statement?
I think on a library by library basis, you can set a new default for the recursion.
This is 120.
That is not 8 for sure. That's a lot
120?
more.
120?
128.
Yeah. So if I tried doing more than 128 things zipped up, I'd run into a problem.
Down, I'll do it.
But I could do, but what I could have done is I could have done 64 and 64 and zip the two of them up.
And zip them out. Yeah.
Yes.
If you're doing 128 things, the compiler whining at you is probably the least of your problems.
Something specifically macros have.
So it's a fun computer science intellectual exercise about how this all works, but at the end of the day, it makes me easily able to say, I just want to write the code that does what I need to do, using the variables that I need, and then zip it all up and pass it back up to the high-level code that's just simply going to call it, totally blissfully unaware of the details of what the algorithm does. It's just knows it's calling that algorithm.
That's cool.
Can you make the code available so we can play with it?
Proprietary.
So
just
the
for
F
folks.
the macro. So what I will do is at the FN mute template, the generic code, and the macro.
Yeah.
I'll just put that onto the meetup chat.
The closure chat on Discord.
So I will do two things. There's a Discord channel for Utah Rust. I will paste it there, and I will also go onto the meetup thing and I will paste it there. So therefore, people have access. I haven't created a GitHub site for this or anything like that. It won't go that far. I'll just paste it in.
I'll do that.
Someone else can put it there.
Just kidding.
I'll write the article.
Just write a check for $1 million. We become rich off of it.
Or the article on it.
Any other questions before we just break into a normal chat this evening and the video goes off? Are we still being recorded?
Yeah.
Oh, okay. See how natural we work. Okay. Any other questions we want to do on the air before just getting to normal networking? Not again. Thank you for coming tonight. Thank you for all the IT stuff, AJ, and thank you, Vivint Smart Homes, for giving us a place to be.
Thank you.
Thank you, very informative.
That was awesome.
The end.
You need one of those direct